Hey everyone, today we are looking at 5-4, which is inequalities in one triangle. So when we're looking at a triangle, there is a relationship between the length of the sides and the size of the angle that is across from it. So the big thing to remember, and the easiest way to remember this, is that big sides mean big angle. Okay? And small sides are going to equal small angles. Okay? So if C is the shortest, if A is the shortest side, okay, in this triangle, then that means that angle A is the smallest angle. All right? So the longer sides are across from the bigger angle. So if B is the longest side, then that means angle B is the largest angle. So it's always the relationship between the side and the angle across from it. If the side is big, the angle will be big. If the side is small, then the angle will be small. And it works the other way as well. If angle A is the smallest angle, then the side across from it is the smallest side. So we can look at it in terms of side lengths. Big sides are across from big angles. Or we can look at it in terms of angle measures, where if I have a smaller angle, okay, then it's going to be across from the small side. So let's take a look. All right, I want to write the angle measures in order from smallest to largest. Okay, so keep an eye on two things. One, make sure you know whether you're talking about angles or sides. And two, pay attention to, is it small to large or large to small? Because those they will be mixed up. Sometimes it'll ask you for sides in order, and then sometimes it'll go small to large, sometimes it'll go large to small. So make sure you're reading your problem critically. All right, so let's take a look at this. So this one, we have side lengths. Okay, this is a side length. It's 33.4 for the length of HJ, 28.5 for GH, and 27.2 for GJ. So the easiest thing that I tend to do is I label my sides. Okay, I go, all right, this one is the longest side, so I'm going to label it with an L for large. 28.5 is the medium side, and 27.2 is the smallest side. So then I can look at my angles from smallest to largest. I know that my smallest angle is going to be across from my smallest side. So we're going to start with the measure of angle H. Or I could say angle H. Either way is fine. It's not going to matter. Okay, so angle H is the smallest angle. Then my medium length side is going to be across from my medium angle. So then angle J is the next smallest angle. And then my longest side is across from my largest angle. So angle G is the biggest angle. So this is how we write our angles in order from smallest to largest. Okay, let's look at part B. All right, I want to write, this time I'm paying attention, sides from shortest to longest. Okay, so when we're looking at these, I am given angle measures. Guys, anytime you're looking at degrees, those are angle measures. And another thing that I cannot emphasize enough is that when we're looking at angle measures, okay, they are in degrees. Those are going to be things that add to 90 or add to 180, or anything that's measured in degrees, we associate with that with angles. As if we add these three sides up here in example A together, they're not going to add to 180. They're not going to add to 90. Like, it doesn't have that relationship. So please make sure you're focusing on the fact that angles go with angles and side lengths go with sides. Please don't mix them. All right. So the first thing that I have to do is, I know two of the angles. I have to find the third angle. So I know that all three angles in a triangle are going to add to 180. So I'm going to do the measure of angle M plus 54 plus 39 is going to equal 180. All right, so 54 plus 39 is going to give me 93. And then when I subtract 93 from both sides, I'm going to get that the measure of angle M is 87 degrees. So I know that this angle here then is 87 degrees. So now 87 is my largest angle. Okay, it's bigger than 54 or 39. Okay, 54 is my next biggest, and then 39 is my smallest. So if I'm writing the sides from shortest to longest, the shortest side is across from the smallest angle. So when we write the side, KM is the shortest side. Then my next biggest is 54. So I'm going to look here. The side across from the 54 degree angle is LM. And the third angle is 87. That is the largest angle. And it is going to be the length of, or it's going to point to KL. So this is longest side is KL. All right. Another thing, guys, is if I'm looking at angle M, the side length should not have an M. So what are the other two letters? K and L. All right. So keep that in mind as that helps you name your sides across, is that you should not use the letter of the angle that you're looking at. Okay. Over here, if I'm looking at HJ, the angle across from it is not going to be H or J, it's G. It's the third letter. So when you look at the angles and the sides all together, then you should have all three letters of the triangle. All right? If you have any questions on that, please make sure that you write that down. Okay, the next thing we're going to look at is whether or not a triangle even exists. Okay, so there are two parts for identifying triangles. One, we need to know whether or not the triangle exists, and then we can also identify what kind of triangle we have. So if we take a look first as whether or not a triangle can exist, I know that the sum of two sides always must be greater than the third side. So I could add any two of these together, and it needs to be greater than the last one. So when I look at thinking about this, if I have the longest side and I add something to it, I know that's already going to be greater than the last side. So for example, and you don't have to write this down because we're going to do some examples, but if I have the sides 3, 4, and 5, if I'm looking at the side length with a length of 5, 5 plus 4 is going to be greater than 3. 5 by itself is greater than 3. 5 plus 3 is going to be greater than 4. So the key here, this I do want you to write down, is I want you to write that the smallest two sides must be greater than the longest. Okay, because that's going to make the difference. Will 3 and 4 add to be greater than 5? Yes, because neither of those are already greater than 5. All right, so it doesn't make sense to do all three of these. It only makes sense to do the one with the smallest two. All right? So the next thing that we're going to look at is looking at the lengths of sides and how I can tell what kind of triangle I have. All right, so we're going to use the Pythagorean theorem to determine what kind of triangle I have. So what I want us to look at is, remember that our Pythagorean theorem is a squared plus b squared equals c squared. So I know that in a right triangle, my legs are a and b. Remember, it doesn't matter which is which. My hypotenuse is c. If I square A, square B, and add them together, it'll be the same thing as C. So that's my right triangle. All right, so what happens if I make C longer and I no longer have a right triangle? Well, then this becomes obtuse. So if I make C longer, then my C squared is now going to be bigger than my A squared plus B squared. All right, if I take that right triangle and I make C smaller, but it's still the longest side, that's also important, okay, then this angle becomes an acute angle. All right, so when C squared is equal to A squared plus B squared, we have a right triangle. When C squared is greater than A squared plus B squared, then it's obtuse. If C squared is smaller, then it's acute. So C squared is small, then the angle across from it is smaller. So this is kind of where we tie into the last one. All right, so let's take a look at some examples here. So first things, I want to know whether or not these work as triangles, because that's first things first. A triangle cannot be acute, obtuse, or right if it doesn't even exist in the first place. So what I'm going to look at is I'm going to start with, is this a triangle? So remember, the smallest two sides must be greater than the third side. So I'm going to start by saying, okay, 3 plus 5, is that greater than 7? All right, 8 is greater than 7, so yes, that works. So then let's look at all three, okay? Is 5 plus 7 greater than 3? Yes. Is 3 plus 7 greater than 5? Yes, because again, 7 is already greater than both of those, so it doesn't make sense to do all three. I want to find the smallest two sides, add them up, and see if they're greater than the third side. So now that I know I have a triangle, I want to know what kind of triangle it is. So the way that I write this is I always do C squared first, because then we're going to match the way that we think about it. I'll see a greater than sign, greater than will be obtuse. I'm going to see a less than sign, less than will be acute. If I don't write C squared first, then that's backwards, and you aren't going to naturally see it the same way. So I'm going to compare C squared to A squared plus B squared. And I just tend to draw a dark box here because we don't know what the relationship is yet. So C squared is always our longest side. So I'm going to take 7 squared and I'm going to compare it to 3 squared plus 5 squared. Remember, it doesn't matter which one we call A and which one we call B. Well, 7 squared is 49. 3 squared is 9. 5 squared is 25. So 49 is going to be over here on the left, and 25 plus 9 is 34. C squared is greater, so this is an obtuse triangle. Okay? So that is what we're looking for here. So again, C squared is greater than A squared plus B squared. If I wrote this the other way, and you don't have to write this down, I would have 34 is less than 49. This is still C squared. C squared is still bigger than A squared plus B squared, but this sign makes you think acute because it's less than. So this is why we always write C squared first. So I want you to make that note. Actually, I'm going to kind of come back here. I want you to make a note somewhere in this box that we always want to write C squared first. Okay, so make this note somewhere up here in this box or somewhere near this theorem. All right. All right, let's look at the next one. Okay, I want to know, is this a triangle? So my smallest two sides are 4 and 6.5. I want to know, are they greater than 11? Well, 4 plus 6.5 is 10.5, which is not greater than 11. So that means that this is not a triangle. Okay? My A and my B are smaller than my C. This does not make a triangle. All right? And our last one here, my smallest two sides are 5 and 5, so it doesn't matter if they're the same or not. And I want to know, is that greater than 10? So 10 is on the left. I have 10 on the right. Is 10 greater than 10? No. Okay, it has to be greater than. It cannot be greater than or equal to. So this is also not a triangle. All right. So if you have questions on that, please make sure that you are writing them down on your notes. It cannot be less than and it cannot be equal to. It must be greater. All right? All right, let's look at our next example here. I want to know whether or not, or what my range is for sides. So I'm going to know two sides of my triangle with this example, okay? I know that I have a triangle with a side length of 6, and I know I have a side length of 11 centimeters. I want to know where could that possible third side be. So this is where we need to remember that my smallest two sides have to be greater than my third side if I add them together. All right? So let's take a look. There are two possibilities here for my unknown side. All right, my unknown side could be smaller than 11. So if x is smaller than 11, I have one option. And I'm going to have another option if x is greater than 11. All right, if x is smaller than 11, that means that my smallest two sides are x and 6. And they need to add to be greater than 11. All right, so I'm going to subtract 6 from both sides, and I'm going to get that x has to be greater than 5. All right, now if x is greater than 11, then that means 6 and 11 are my smallest two sides. So I'm going to do 6 plus 11, and that has to be greater than x. So that means that x has to be less than 17. So my final answer is that x has to be between 5 and 17 in order for there to be a triangle. All right? So again, look at the shortcut. Subtract the numbers. Add the numbers, and that'll give you your range. Notice there are no equal signs. It is the smallest number on the left, the largest number on the right. We always write it this way. So anytime you're looking for a range, your answer is going to be in this format. All right? If you have any questions about that, please make sure you write them down. So what we're going to go ahead and do now is go ahead and pause the video and try these 4 problems on your own. I'm also going to add in here to go ahead and tell me what kind of triangle it is. If you can make a triangle, well, let me rewrite this. We're going to say classify. So add in here that I want you to classify the triangle. And that means determine whether it is acute, obtuse, or right. All right? So please go ahead, try these. Make sure you add in the classify. All right, pause your video, go ahead, work these out, and then press play when you're ready. All right, so go ahead and check your work. Number 1, make sure you're paying attention to the fact that we're asking you for sides. So you need to just subtract 90 and 22 from 180 to get that this angle is 68. So this is our largest angle, our smallest angle, and our medium size angle. So the mediums are going to be across from each other. All right. Next set, we want to know whether or not they have the given, whether or not the triangles exist, and classify if it does. So when I look at number 2, 8 plus 13 is 21. 21 is not greater than 21, so this is not a triangle. All right, here, when I look at this one, 6.2 plus 7 has to be greater than 9, and it is. So then we're going to do c squared, which is our longest side, and compare that to a squared plus b squared. All right, 9 squared is 81. 6.2 squared is 38.44. 7 squared is 49. Add these together, I'm going to get 87.44 over here. So c squared is smaller than a squared plus b squared, which means my triangle is acute. All right, number 4, if x is the smallest side, I know that it's going to be less than 22. So that means 17 and x are going to be my smallest two sides, and they have to add to be greater than 22. So x has to be bigger than 5. And then if x is larger than 22, then 22 and 17 are the smallest two sides, and they have to add to be greater than x. So then my range is somewhere between 5 and 39. Can be any value of x that will maintain the fact that I have a triangle. All right. So again, if you have any questions, I can't stress enough how important it is that you ask them. Make sure you write them down, and we will see you in class. Have a wonderful day.